Chapter 3, Sequence and Series. A sequence is a function f whose domain is the set of natural numbers. The value f1, f2, f3 and so on are called the terms of the sequence. A series is the sum of the terms of a sequence. We write the sum of the first n term of a Sn, where Sn equal to first term, second term until the nth term. Let's look at the example. Find the first 5 terms of the sequence defined by each formula. Tn equal to 2n squared minus 1. So for the first term, T1. Substitute 1 into T and N. So we'll get here 2 minus 1 equal to 1. The second term, T2, substitute 2 into the formula. So 2 squared, 4, multiply with 2, 8, minus 1, 7. And the third term, 3 squared, 9, multiply with 2, 18, minus 1, equal to 17. The fourth term, 4 squared, 16, multiply with 2, 32, minus 1, equal to 31. And the last one, fifth term, 5 squared, 25, multiply with 2, 50, minus 1, 49. So we have the first 5 term, 1, 7, 17, 31 and 49. The second formula, Tn equal to n over n plus 1. So we find the first term, substitute 1. So we'll get here 1 over 2. T2, 2 over 2 plus 1. So we get 2 over 3. The third term, 3 over 3 plus 1. So we'll get 3 over 4. The fourth term, 4 over 4 plus 1 equal to 4 over 5. And the last one, fifth term, 5 over 5 plus 1 equal to 5 over 6. So we get all the 5 first term, 1 over 2, 2 over 3, 3 over 4, 4 over 5 and 5 over 6. Next question. Find the n terms of the sequence whose first several terms are given. Okay, for the first sequence, -2, 4, -8, 16 and -32. So let's rewrite first. The first term, -2, 4, -8, 16, and the last term here, negative 32. So if we look at here, we have 2, 4, 8, 16, and 32. So to get 2, it's either 2 times 1 or to the power of 1. Okay, so the second term, 4, it's either 2 times 2 or 2 to the power of 2. For the third terms, to get it, either 4 times 2, or if you want to relate it with the number 3, is 2 to the power of 3. From here, we know the pattern. It's going to be 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and 2 to the power of 5. Okay, so the next one, we consider the sign negative. So to get the first one, negative 2, so it can be negative 1 to the power of 1. To get positive 4, negative 1 to the power of 2. Okay, so we know the pattern, and the answer will be negative 1 to the n multiply with 2 to the power of n. And we can write it as negative 2 to the power of n. Let's look at the second sequence. 1 over 2, 3 over 4, 5 over 6, 7 over 8. So to make it clear, let's write in term, first term, 1 over 2, 3 over 4, 5 over 6, and 7 over 8. Now we look at the numerator, 1, 3, 5, and 7. So we try to relate the terms with the number we have here, 1, 3, 5, and 7. So to get 1, either 1 multiply with 1 or 2 multiply with 1 minus 1. So we get 1. The second term, 2 multiply with 1, then we should get 2, but here 3. But if we use 2 multiply with 2 minus 1, then we will get 3. The third term, 3 multiply with 2 minus 1, so we will get 5. From here, what we already know, for the numerator, 2 multiply with 1 minus 1, so we'll get 1. 2 multiply with 2 minus 1, so we will get 3. 2 multiply with 3 minus 1, so you will get 5. 2 multiply minus 1, so you will get 7. Now we move on to the denominator, 2, 4, 6, and 8. So from here we know the pattern. It will be 2 multiply with 1, 2 multiply with 2, 2 multiply with 3, and multiplied with 4. And now we know the pattern and we get the formula in n term. Tn equal to 2n minus 1 over 2n. So the value from n equal to 1 until infinity. Next subtopic, the partial sums of a sequence, also known as series. For the sequence T1, T2, T3 until Tn, the partial sums are S1 equal to T1, S2 equal to T1, the first term, plus the second term, S3, first term plus second term plus third terms, and Sn is a sum from T1 until the Tn. From the series, we can get the n term by minus the series with the previous series. So, note here, S1 is equal to the first partial term. So, the note here, S1 is called the first partial sum. S2 is called the second partial sum, and so on. So, S1, S2, S3 until Sn are called sequence of the partial sum. Let's look at the example. Find the fourth term, fifth term, and fourth partial sum plus fifth partial sum for the sequence given by 1, 4, 7. Okay, so from here we know the first term is 1, second term 4, the third term is 7. If you look at the common difference between the first term and the second term is 3. 1 plus 3 equal to 4, and 3 plus 4 equal to 7. So we know already the pattern, and we can get the fourth term here. 7 plus 3 equal to 10, and the fifth term 10 plus 3 equal to 13. Next, we're going to find the fourth partial sum, S4. So, to get S4, the first term 1 plus 4 plus 7 until the fourth term plus 10. So from here we will get 22. Next, the fifth partial sum, S5. 1 plus 4 plus 7 plus 10 and plus 13. So from here we will get 35. From here, S4 plus S5 is equal to 22 plus 35. So we will get 57.